So this is the GUI for an audio watermarking using iris features as a digital watermark. So this button will give you the option of selecting an image which will be processed to generate a watermark. So if we click here, it takes you to the database, and from the database, let's say I pick sample number 25, and one is the left eye. I pick the first sample of the left eye. Now this is processing. The status bar is indicating that the process is on, and once the process is on, there will be an indication. So this is what it shows, that the watermark is generated. Now this button will give you an option of seeing the watermark. So once I click the watermark, this option you can see is the binary pattern of the template generated here is displayed. Let's check the power spectral density of the watermark. This button will give you the option for doing that, and the power spectral density of the watermark can be seen. It's interesting that the x-axis is the normalized frequency, and the y-axis is the power spectral magnitude, and it can be seen here that the power spectral density is distributed uniformly. You can see here it is distributed uniformly from the lower frequency components towards the higher frequency components, which indicates that low pass filtering or other signal processing attacks may not completely remove the watermark from the entire spectrum. Now here, this is the module which will give you the indication. We have an option of seeing the size of the watermark, number of bits also. Let's see, it's 9600. So the template generated which will be used as a digital watermark has got 9600 bits, which you can see is a fair amount, a good number of bits which can be used as a watermark, and maybe the identification and authentication may be good enough because of this number of 9600. Okay, now this module gives an option of embedding the watermark into the host signal. Let's say we click the host signal from here, and we choose, let's say, okay, we choose classical 2, one of these samples, audio samples over here. Now the sample is displayed. Now this will give you an option of embedding the watermark in the host signal. I click here, so you can see the watermark is embedded. The watermark is embedded, and once the watermark will be embedded, the indication will come. The status bar is indicating that the process is on. The process is on, and once the process is on, we can have an indication that the watermark has been inserted in the audio file. Okay, so here we go, and now you can see that the watermark. So this message is displayed. And once we click OK, so here we go, and this option will give you to see the watermarked audio signal. As you can see, there is no much difference between this one and this one. So perceptually, we cannot see any difference, and you can play the audio signal over here. There's an option over here to see the watermark original and watermarked audio signal. If you click this button, this will give you an option to see clearly and visibly, and apparently there is no much changes between the original audio signal and the watermarked audio signal, which is evident from the two figures. We close these two figures, and I think you can see there's an option to play the original signal. Here we go. The original signal is played at the normal sampling rate of 44.1 kilohertz. And this is an option to play the watermarked audio signal. The watermarked audio signal is played. So we can see apparently there is no corruption of the signal, and there is no distortion or perceptually disturbing effects have not been induced because of the watermarking effect, which is evident after hearing the watermarked audio signal from here. Now this will give you an option to see the payloading. So let's see, we click it here, and the payload is 196 bits per second, which is fairly a considerable amount of high payload, indicating that one of the challenging requirements of watermarking, that maintaining a good payload is attained. The signal to noise ratio, let's see how it goes. Signal to noise ratio is 27.24 decibel, which is fairly good enough, because 25 decibel is considered to be a good threshold. Anything above 25 threshold can be considered that the noises or the perceptual disturbances may not be audible to the human audio system. So we can consider that a good amount of payload is achieved, and the perceptual property of the signal is also fairly maintained for two challenging requirements of the audio watermarking is fairly maintained over here, and this gives an option of, and this is the block diagram for seeing the watermark extraction. This gives an option to apply an attack. Let's say I apply a Gaussian signal attack to this and apply an attack. So let's say I take the watermark audio signal from here. So the Gaussian noise is applied to the watermark signal, and then we have to actually see that whether the watermark can be extracted from that attack signal. Now at this one is okay. Now I think we can see here there's an option of seeing the watermark signal. You can see the watermark signal is displayed in this figure. So now the challenge is to recover the watermark from the attack signal. This button will give you an option of extracting the watermark from the attack signal. Let's see, here we go. And so we have to find the attack signal. So I think this is the attack signal. I click this attack signal, and this status bar is indicating that the watermark extraction is under process. Let us see how it goes. So once the extraction is done, we would like to see the quality of the watermark that is extracted in terms of bit error rate and also the correlation of the watermark. Let's see, here we go, and now okay, so there's a message displayed that the watermark is extracted. Now let's calculate the bit error rate of the watermark. Let's see how it goes. So we can see here that it's calculating the bit error rate. Bit error rate is 0.895%, which is less than 1%. So we can say that the extraction process, even under the seriously challenging attacks, has been considerably good. Let's see how the correlation goes. The correlation between the original watermark and the extracted watermark is approximately 9.82, so it's fairly good now. So the bit error rate percentage and the correlation percentage indicates that the quality of the watermark that is extracted from the attack signal is fairly good enough. Now this is the last block which gives an option for identification of the watermark from the database. Now here I go. I click the identification part, and so this was the extracted watermark which was stored in the database. I click this. I selected this, and the identification process is under progress. The status bar will indicate once the identification is done. The identification process may take some time because it is running across a huge database and trying to match the features of the extracted watermark with those which is existing in a database. So depending on the size of the database, this may be a little time-consuming process, but then the accuracy is not compromised. Okay, so here we go, and finally the taskbar says that it's done. So this message indicates the identification is done. So I say it's okay. So let's see how it goes. So if I click this show identification curve, it indicates that matched with RE sample 25. The peak curve in this graph indicates a huge normalized correlation between the 25th sample and the extracted watermark, and you can see the rest of the correlation is less than 1, which gives an opportunity of having a good enough thresholding method to have a unique identification. So this indicates that there has been unique identification of the extracted watermark from the signal even under challenging attacks.